Hey guys, in my previous video I have discussed about the three-dimensional geometry and vectors in space. Today I'm going to show you different questions and their solutions on coordinate geometry. So under this unit I will raise the issues related with lines, circles, parabolas, ellipse and hyperbola. So stay with me. The first question is, if a line with angle of inclination is 3 pi over 4 passes through the point 0, 1, which one of the following is the equation of the line? Here we are asking the equation of the line passing through the given point with this inclination 3 pi over 4. So the given thing, the slope of a line can be expressed in terms of the inclination. M is equals to tan theta, and the line passes through the point 0, 1. So we can determine the equation of a line. The required thing is the equation of a line passing through the given point. So now the slope is tan of the inclination, which is 3 pi over 4, and this is the same as tan of 135 degree, which is -1. Therefore the slope is -1. Here the slope is -1. So the equation will have this form: y is equals to -x plus b. Now to determine b, use this point 0, 1. In place of x, use 0. In place of y, use 1. So y is 1, x is 0 plus b. Therefore b is 1. So the equation of a line will be y is equals to -x plus 1. This is the equation of the line. So our answer will be A. Consider a circle whose center is on the x-axis. There is a circle whose center is on the x-axis. If the line given by y is equals to x is tangent to the circle at some point of tangency 2, 2, what is the equation of the circle? Roughly this graph that you can see here describes the information given here in question number 2. As you can see, the circle is lying, the center of the circle is on the x-axis. Call or give a name for the center C with entries h, 0, because the second entry is 0 on the x-axis, and this point of tangency is 2, 2. The given line y is equals to x is tangent to the circle. So we need to determine the equation of the circle based on this information. So from the graph that you can see here, we have a line, a tangent line to the circle, y is equals to x. The slope of this line, the slope of this line, m1, is obviously 1. And we know that the line segment passing through the center and the point of tangency forms perpendicular. So if we call this line, the slope of this line, if you denote it by m2, so this m2 should be -1, because if two lines are perpendicular to each other, the product of their slope must be -1. So m1 times m2 must be -1. Since we know m1, or the slope of the tangent line, the unknown slope m2 should be -1. So this m2, knowing m2 is very important to determine the first entry of the center. So we know that the slope m2 is defined as the difference between 2 minus 0, 2 from here, 0 from here, over take the difference 2 with h here, so 2 minus h. So this ratio is minus 1. So from this you can get that 2 over 2 minus h is equals to minus 1, which is equals to 2 is equals to minus 2 plus h. So h becomes 4. You can take this to the left, so h becomes 4, where h is the first entry, or the center of this circle will be 4, 0. We know the center of the circle. We know the point of tangency 2, 2. So using distance formula between the center and point of tangency, we can determine the radius of the circle. So our radius of the circle will be 4 minus 2 the whole square plus 0 minus 2 the whole square, which is under the radical 4 plus 4, which is radical 8. This is r. So r is equals to radical 8, means r square will be 8. Now we have the center. The center of the circle is 4, 0, and the radius is radical 8. Therefore, the equation of the circle becomes x minus 4 the whole square plus y square is equals to r square. So this implies x minus 4 the whole square plus y square is equals to 8. This is the equation of the circle. So our answer will be C. What is the vertex and the equation of the directrix respectively of the parabola x plus y square plus 2y plus 1 is equals to 0? So here the equation of a certain parabola is given that x plus y square plus 2y plus 1 is equals to 0. From this equation we are asked the vertex and the directrix. So to determine the vertex and directrix, we need to write this equation in standard form. So the equation becomes y square plus 2y plus 1 is equals to minus x. This implies y plus 1 the whole square is equals to minus x. This is a horizontal parabola which is opened to the left. We know that the standard equation of a horizontal parabola which is opened to the left is given by y minus k the whole square is equals to minus 4p times x minus h. Here the vertex of this parabola will be hk, and the directrix, the equation of the directrix becomes x is equals to h plus p. Okay, so we need to be familiar with this thing. So based on this equation of parabola y plus 1 the whole square is equals to minus 4 times 1 over 4 x minus 0. Okay, you can make it in this form. So from this we can get that p is 1 over 4, and the vertex will be 0, minus 1. Okay, this is a complete or a standard form of the parabola. So our vertex will be 0, minus 1, and p is known. Therefore the directrix becomes x is equals to h plus p, which is x is equals to 1 over 4 is the directrix. This is the equation of the directrix. So from the choice, C will be the answer. The orbit of Mercury around the Sun forms an ellipse with eccentricity 0.206, length of major axis 1.16 times 10 to the power of 8 kilometer, and the Sun at one of the focus. Which of the following is the best approximation of the maximum distance from Mercury to the Sun? Here on this figure, here is the figure that shows the ellipse. Okay, in ellipse there are terminologies: the focus, the center. Okay, the focus we usually denote it by F, the center by C. Okay, there are two focuses, and the major axis, which is the longest chord, called this is A, and say this is A prime. The distance between A and A prime is called the major axis, which is assumed to be the longest chord. And from the given problem, we have a certain Mercury traveling on this kind of trajectory. Okay, the path of an orbit is elliptic. So assume the Mercury is traveling on these green curves, and the Sun is at one of the focuses. Say the Sun is here. Assume the Sun is on this focus. So the question is, what is the largest or the maximum distance from the Mercury to the Sun? Or if we think the Sun is here on F prime, the shortest distance will be from this point to this one, and obviously the longest or the maximum distance from the Mercury to the Sun will be attained at this point, at A prime. So we just try to calculate the distance from this F prime to A prime. That will be the maximum distance from the Mercury to the Sun. So from the given information, the length of the major axis, that means between A and A prime, usually we denote it by 2 times A, is given as 1.16 times 10 to the power of 8. Now dividing both sides by 2, it will give us A becomes 0.58 times 10 to the power of 8 kilometer. So we can change this as 5.8 times 10 to the power of 7 kilometer. This is a semi-major axis. The other information is the eccentricity. Eccentricity is denoted by U and is defined as C over A, where C is the focal length, the distance from the center to the focus, one of the focus, and the small a is the semi-major axis, the distance from the center to the one of the endpoints on the major axis. So this is given as 0.206. So from this we can get that C is equals to 0.206 times A. This means 0.206 times A is 5.8 times 10 to the power of 7. So let's keep this thing as it is. Okay, so our C is 0.206 times 5.8 times 10 to the power of 7 kilometer. this is the value of C, or the distance from the center to one of the focus. Therefore, the maximum distance between the sun and the Mercury is the maximum distance between the Mercury and the sun will be the length C plus A. So C, or the focal length plus semi-major axis, will be the largest or the maximum distance from the sun to the Mercury. So C is 0.206 times 5.8 times 10 to the power of 7, plus A is 5.8 times 10 to the power of 7. So taking out the common things, so this is the same as 0.206 plus 1 times 5.8 times 10 to the power of 7 kilometer. So this value is 1.206, and you multiply this by 5.8, the result will be approximately 6.96 times 10 to the power of 7 kilometer. This is the maximum distance from the sun to the Mercury. This is the maximum distance from the sun to the Mercury. Therefore, our answer will be D. If x squared minus 6x plus y squared plus k is equals to 0 is the equation of a circle with radius 2, then what is the value of k? Here, to find the unknown value of k, we need to write the equation of a circle. We need to write the equation of this circle in standard form. The given equation is x squared minus 6x plus y squared plus k is equals to 0, and the radius of this circle is 2. So let us try to rewrite in standard form. So this becomes x squared minus 6x plus y squared is equals to minus k. We need to take this to the right. So using completing square method, this can be written as x squared minus 6x plus 9 minus 9 plus y squared is equals to minus k. Here I did nothing except adding 0 in the original equation. There is no difference between these two equations, because in the second here I added only 0. So the equation is unchanged, no more change on the equation. So using completing square method, this can be written as, this part can be written as x minus 3 the whole square. Then you can take this negative 9 to the right, and let us keep y on the same side. Y squared is equals to 9 minus k. Definitely this is a standard form with center at 3, 0, and the radius of the circle r squared and 9 minus k are the same, but r squared means r is 2, so 4 is equals to 9 minus k. So from this k will be 5. 9 minus k is 4 means k is 5. Therefore, the answer for this problem is B. A parabola with focus 3, minus 1 has directrix y is equals to 3. Which one of the following is the equation of the parabola? Ideally, this graph with the broken line as a directrix, if this broken line is a directrix, which is y is equals to 3, in the xy plane, say this is the x-axis and this is the y-axis. So the directrix is given. The other information about the parabola is 3 comma minus 1 is the focus. 3 comma minus 1 is, say 3 comma minus 1 is the focus, which is on the fourth quadrant, say 3 comma minus 1. So now we can think of about the parabola. If the directrix is a horizontal line, we expect a parabola to be an upward or downward parabola. Generally, we expect a vertical parabola. So for this case, the focus is below the directrix. Therefore, the parabola will be downward because the directrix and the parabola will never intersect. So if the focus is here, the vertex will be somewhere at equal distance from the directrix, right? So if the vertex is here, ideally the vertex will be a midpoint for the focus and the point, the shortest distance on the directrix. So let us construct a vertex of the axis of the parabola passing through the vertex. So I'm not good here in sketching. Anyways, assume this vertical line is the axis of the parabola that divides the parabola into two equal parts. So it is assumed to be a line passing through the vertex, which is perpendicular to the directrix. Since this vertex is a midpoint for the focus and the point on the directrix, here at this point the value of x is 3, because vertically the x value is common and the y value is also 3. So the vertex is a midpoint for the focus and the point 3, 3 and 3 comma minus 1. So the first entry will be 3. The second entry is the average of 3 and minus 1, which is 1. So now we have the vertex of the parabola, and P is the distance from the vertex to the focus. The distance from the vertex to the focus, or the focal length, is 2. You can measure the difference between 1 and -1. So P is 2. So from here we can see that P will be 2 and the vertex is obtained 3 comma 1. Therefore the equation of a parabola will be x minus 3 the whole square is equals to negative 4p into y minus 1. Why negative? Because the parabola is downward. So P is already 2, so this becomes minus 8 into y minus 1. So the equation of the parabola with the given directrix and focus is x minus 3 the whole square is equals to minus 8 times y minus 1. So the answer will be B. For what value of B does the parabola P of x is equals to ax squared plus x plus b passes through these 2 points? Okay, so here we are asking the value of P in which the parabola passes through the given these 2 points. So the function is P of x. Our parabola is P of x is equals to x squared plus x plus b. P means the value of the function, y is equals to ax squared plus x plus b. Since this parabola passes through these 2 points, let us take the points. In place of y, use 5. 5 is equals to a times, in place of x, use minus 1. Minus 1 squared plus x is already minus 1 plus b. So minus 1 squared is 1. So this becomes 5 is equals to a minus 1 plus b. So this becomes a plus b will be 6. So say this is equation 1 or whatever you like. The other thing is use these points. In place of x, use 2. In place of y, use -1. So this becomes -1 is equals to a times 2 square plus 2 plus b. This means -1 is equals to 4a plus 2 plus b. So taking this number to one side, 4a plus b becomes -3. So we have another equation with 2 unknown. So from equation 1 and 2, we will have simultaneous equation of 2 variables. A plus b is 6, 4a plus b is -3. So let us multiply the first equation by -1 and the second one by 1, so that b will be eliminated. So this becomes -a minus b is equals to -6. The second equation is 4a plus b is equals to -3. Now you can sum it up. 4a with -a, it is 3a. b will be eliminated. Minus b with b is 0. -6 with -3 is -9. So a becomes -3. So if a is -3, you can use one of the equation. You use a plus b is equals to 6. A is -3. -3 plus b is equals to 6. So take this to the right. B becomes 6 plus 3, or the value of b is 9. So our answer will be A. If two lines y is equals to x and y is equals to x minus 1 are tangent to the circle at 2, 2 and 4, 0 respectively, then what is the equation of the circle? Here you can see the graph. Ideally, the statement looks like this in graphical form. There are two lines. These two lines are parallel. Y is equals to x and y is equals to x minus 4 are parallel because they have the same slope. Okay, so we are expected to sketch like this, and these two lines are parallel. At the same time, they are tangent to the circle at 2, 2 and at 4, 0. So what is the equation of the circle? That is the question. So if they are parallel, if these two tangents are parallel, we expect a line segment will form perpendicular at the point of tangency. Here it forms, in both ends there is perpendicular form. So a line segment passing through the center will be perpendicular to the two tangent lines, and the center for this circle will be a midpoint for the point of tangency. If it is a midpoint, add 2 with 4 and divide it by 2, the result is 3. Again, add 2 with 0 and divide it by 2, the second entry will be 1. Therefore, the equation of the circle, I mean the center of the circle, will be 3, 1. This is the center of the circle. The other thing, we need to determine the radius of this circle. The radius is the distance from the center to one of the point of tangency. So let's take this point 2, 2 with the center. So calculating the distance between these 2 points, 3 minus 2 the whole square plus 1 minus 2 the whole square. This means radical 1 square plus minus 1 square. Both are 1. So the result is radical 2. So R is radical 2 implies r square is r is radical 2 implies r square is 2. Therefore, the equation of a circle with center 3, 1 and radius radical 2 will be x minus 3 the whole square plus y minus 1 the whole square is equals to r square, which is 2. So this is the equation of a circle. The required equation is this one. Therefore, our answer is C. A semi-elliptic arc over a tunnel for a road through mountain has a major axis of length, 80 meter, and height 30 meter at the center. What is the equation of the semi-elliptic arc over the tunnel if the center is considered as the origin? Here, there is a tunnel through the mountain. Okay, this open part is the tunnel through a mountain. Okay, so the major axis of this tunnel is 80 meter. The whole this thing is 80 meter. That means the semi-major axis will be 40 meter. Okay, so this A will be 40 meter. A is the notation that we use for semi-major axis, and 30 meter is the height at the center. This is the height of the tunnel at the center, which is 30 meter. We usually denote it by B. B is 30 meter. This B is the semi-minor axis, and A is semi-major axis. And this point, the point in which the semi-major axis and the semi-minor axis intersect is given as the origin. The two lines intersect at the origin here. So from this information, we are asked to give the formula for the equation of the ellipse. Basically, the ellipse is a horizontal ellipse because the semi-major axis or the major axis is horizontal. So we take x square over a square plus y square over b square is equals to 1, where the center is the origin, as it is given here. So A is already known. A is 40. Therefore, the equation becomes x square over 40 square plus y square over 30 square is equals to 1. So the equation of the ellipse will be x square over 40 square is 1600, and 30 square is 30 times 30, which is 900, is equals to 1. This is the equation of the ellipse. What is the focus of the parabola y square plus 4y plus 8x is equals to 4? So to determine the focus, the vertex, the directrix, anything regarding the parabola, the first thing is we need to write the given equation of parabola in standard forms of the equation of a parabola. So we need to apply some completing square method here. Y square plus 4y is equals to minus 8x plus 4. So applying completing square method, we can write this like y square plus 4y plus 4 minus 4 is equals to minus 8x plus 4. These two equations are the same. I added 0, the only thing. So here, this part, only this part, y square plus 4y plus 4 is y plus 2 the whole square. Y plus 2 the whole square is equals to, you can take this to the right side. So this is minus 8x plus 8. So this can also be written as y plus 2 the whole square is equals to minus 8 into x minus 1. So this is definitely a parabola, a horizontal parabola, which is opened to the left due to this negative sign. It is opened to the left, and 4p is 8. That means p is 2. That means the p is the focal length. The first thing that we need to do here is write the vertex. The vertex of this parabola is 1 comma minus 2. You can solve this for the arrow to get x value and solve this one to get y values. Therefore, this is the vertex. Since this parabola is a horizontal parabola which is opened to the left, assumed here is the vertex, which is 1 comma minus 2. So to find the focus, we need to move p units horizontally. That means at the vertex x is 1. Now at the focus x will be minus 1. When we move 2 units to the left, x will be minus 1 and y remains as it is. Therefore, the focus of this parabola is minus 1 comma minus 2. So this is the focus. So our answer will be B. The equation of the line that passes through 1 comma minus 1 and perpendicular to 3x plus 4y plus 6. We are asked the equation of a line passing through 1 comma minus 1. We are asked the equation of a line passing through a line mx plus b passing through 2 comma minus 1 and perpendicular to this one. So we need to find first the slope of the known line. So the slope of this line can be obtained by rewriting the equation first. 3x plus 4y is equals to 6 means 4y is equals to minus 3x plus 6. So y becomes minus 3 over 4x plus 4 over 6. So the slope of the given line, the line is minus 3 over 4. So since the two lines are perpendicular, m and say this is m prime, m and m prime are perpendicular means the product of their slope is minus 1. So m prime is already minus 3 over 4 times m is equals to minus 1. So from here you can get that m is 4 over 3. So the slope of the unknown line is 4 over 3. So use 4 over 3 here. So the equation becomes y is equals to 4 over 3x plus b. Now this line passes through 2 comma 1. Use x to y minus 1 to get b. So y is minus 1 and x is 2. So from here you can get b is equals to minus 1 minus 8 over 3 because 4 times 2 is 8. So this is minus 11 over 3. So the equation of the line becomes y is equals to 4 over 3x minus 11 over 3. Now you can multiply both sides by 3 to rewrite this equation. So it becomes 3y is equals to 4x minus 11. Okay, so let us check from the choices, or you can rewrite this thing as minus 4x plus 3y is equals to minus 1. So you can directly get this thing from the choice. A satellite moves along a hyperbolic curve whose horizontal transverse axis is 24 kilometers and an asymptote y is equals to 5 over 12x plus 2. So what is the eccentricity of the hyperbola? So let us write the formulas for such hyperbolas first. The hyperbola is a horizontal hyperbola. So the standard equation for a horizontal hyperbola is x minus h the whole square over a square minus y minus k the whole square over b square is equals to 1, where a is the semi-transverse axis and b is semi-conjugate axis. So the transverse axis, that means 2a is 24. This implies a is 12, dividing both sides by 2. We have a. To determine the eccentricity, eccentricity is defined as c over a, where c is the distance from the center to the focus, a is the semi-transverse axis. So we have already a values. We need to determine c. So the other information that we need regarding this hyperbola is the asymptotes of the hyperbola is given by y minus k is equals to plus or minus b over a into x minus h. This is the formula for the asymptotes of a hyperbola. But the one of the asymptotes of the hyperbola is given as y is equals to 5 over 12x plus 2. Here, this is the value of a, and this 5 is this 5 should be the value of b. So b is already obtained here from the asymptotes. So there is a relation for hyperbola. The relation between a, b, c is c squared is equals to a squared plus b squared. So a squared is 12 squared and b squared is 5 squared. The result is 144. 144 plus 25. The result is 169. So c squared is 169, means the c value becomes the square root of 169, or c is 13. Therefore, the eccentricity E is c over a, means c is 13, a is 12. Therefore, 13 over 12 is the eccentricity of the hyperbola. The other problem related hyperbola is, if this is the equation of a certain hyperbola, which one of the following represents the equation of an asymptotes of the hyperbola? Here, the equation of the hyperbola is x minus 2 the whole square minus y minus 2 the whole square is equals to 1. Or in standard form, you can make, or you can write it like this: x minus 2 the whole square over 1 square minus y minus 2 the whole square over 1 square is equals to 1. This means both a and b are 1. Here we can get that both a and b are 1. The other thing is the formula for the asymptotes is y minus k is equals to plus or minus b over a into x minus h. Here hk is the center of the hyperbola. So our hk values are, h is 2 and k is also 2 from here. Okay, so let us apply everything here. The asymptotes will be y minus 2 is equals to plus or minus 1 over 1 x minus 2. So there are two possibilities. One thing is y minus 2 is equals to positive x minus 2. The other thing is y minus 2 is equals to the negative of x minus 2. So from here, y is equals to x or from here y minus 2 is equals to minus x plus 2. So this means y is equals to minus x plus 4, or you can make it y is equals to 4 minus x. They are the same. So these two are the asymptotes of the given hyperbola. So let us search this one or this one or both. So from the choice we have one asymptote in A. So the answer for this is A.